On CCNP 2.0 root VPN technologies, so far we have discussed about configure and verify GRE, describe dynamic multi-point VPN or DMVPN using single hub. In this section, we're going to discuss about easy virtual networking or EVN. So let's discuss more about EVN, what is the use case of EVN, what is advantage of EVN, and what is the limitation of EVN. So basically it is simplify LAN virtualization and provide services separation on shared network infrastructure. So you may have a couples of groups and you may have a couples of user and maybe third party vendor who want to keep their traffic separate from each other. On that case, we can apply easy virtual networking or EVN inside LAN. So it cannot be deployed on WAN because of it only support on interface which support .1Q encapsulation. In other words, we can say on Ethernet technologies. But it is not 100% true to connect with WAN with Ethernet encapsulation technologies. We may have some other technologies like HDLC, frame relay, MPLS, or some other things. So because of that, we cannot deploy easy virtual networking on WAN, but it is good for LAN because there is couples of features that make unique from other virtualization technologies like policy-based routing or some other technologies. So let's discuss rest of thing. It offer lightweight shared services, simple configuration in support IPv4 and IPv6 as well. So you don't need to require a lots of resources in order to implement EVN, and the configuration is simplest, and it also support IPv4 and 6. So we have a topology or we have an example of EVN. Let's see how it works. So what I guess, it is basically a VLAN technologies that add some other components in order to make the traffic separate. So let's say we have a three vendor blue, vendor yellow, and vendor green, and we want to make their traffic separate from each other. So what we're going to create, we're going to create a VRF on every devices, but along with a special thing or a special components which is known as EVN tag or VNet tag. Shortly we're going to discuss about that make your traffic separate from each other or each virtual network. So it is not necessary for every time you're going to purchase a new device for new groups. Using existing infrastructure, you can share using network virtualization and keep their traffic separate from each other. So this is how, or this is technology where we can implement EVN on top of your LAN or top of your network. So basically EVN has some components which we're going to discuss that makes clear how does actually EVN works. It uses multi VRF or a VRF Lite, VNet tag, which is the new thing, VNet trunk interface, as well as root replication feature. So these three things which is new for you, maybe it is new for you, which I guess going to utilize only EVN or easy virtual networking. So hopefully we also know what is the task of multi VRF or VRF Lite. Basically it allowed to use network or a router virtualization on existing infrastructure. Multi VRF offer MPBGP and label-free network segmentation solution. So obviously we can go for the MPLS, but in MPLS we have a dependency like MPBGP or multi-protocol BGP and labels. But using multi VRF in EVN, we can go for deploy different network using VNet tags. So basically VNet tags are differentiate virtual network along with the name. On normal configuration, we just need to define the VRF name and some other things like root target and root distinguisher. But in case of EVN, you don't require to configure this thing. This is how make different from other virtualization technologies or other network virtualization technologies. The next thing is VPN tag. So it is a virtual network instance identifier like a VLAN tag inside your switches. So inside your switches we add VLAN tag or like .1q or ISL in order to separate the traffic from one switch to another switch. So same thing we're going to use, but it is little bit different than VLAN because it's going to work using couples of other tools or other feature like multi VRF and trunk interface. So the tag which we can utilize from 2 to 4094, or other word we can say we can deploy up to these number of virtual network on existing infrastructure. VNet tags should be identical on all router. So for example, let me go ahead and discuss a little bit more about this. So suppose if we decide blue is going to assign uh, a tag which is 1003, that should be identical to all devices which is running inside which is running EVN. So likewise yellow one as well as green one, whatever tag you have defined on particular router or core devices, that's supposed to be identical on every devices so that it allow to work your EVN correctly. Likewise, uh, yes, VNet trunk interface. So basically every VRF or other VPN technologies, or excuse me, LAN network virtualization technologies required a dedicated interface in order to work it correctly. But in case of EVN, it is not 100% true. So it used to eliminate requirement of dedicated interface for each VRF. Backbone or core network devices interface work as a VNet trunk interface. So as we seen here, so consider we have this router R2 which is middle of the network or it is a backbone device, and these are the edge devices. As we can see, we supposed to need to run trunk encapsulation or VNet trunk encapsulation on this interface which is belong to the core network, but we do not require to run trunk interface on the edge interface because they are going to connect with the end host or the server. So backbone or core network, and then after VNet tags are used to differentiate traffic on it. So whatever VNet tag we have defined in VRF, it automatically going to use in trunk as well. So virtual network traffic restriction can be configured from VNet trunk. So obviously we can deny or permit particular virtual network on your infrastructure on configuring your trunk interface or VNet trunk interface in order to filter the traffic. The next killer application is, or a killer feature is, you can replicate your global routing table or other virtual networks to some other virtual network. So it is used to replicate VNs or global routes from each other. We can go for route replication feature, which is new. It removed dependency of BGP. So far we have discussed in VRF, in order to leak the global routes in VRF, we supposed to have a BGP, and then we can redistribute your global routing table inside the virtual instance of routes. But in case of VNet, it is not true. You don't require like BGP attributes like target and route distinguisher in order to replicate your global routing table inside your virtual network. You just need to execute command using route replication and what route we want to replicate inside VMs or from one VMs to other VM. But replication route are not redistributed automatically. Obviously, it required some sorts of routing protocol in order to replicate those routes inside your virtual network. So for the that we deploy EVN or easy virtual network inside LAN, but it is not true to apply on WAN because in most of cases we do not have a Ethernet interface goes to connect with the WAN. Obviously there is some technology which offer Ethernet encapsulation but not 100% time. So let's go ahead and perform a little bit practical on it. That makes sense to understand it lot. And one more thing would like to discuss. It is not going to support on every platform. It required some special platform where we can implement easy virtual network. Unfortunately, my current CISCO device are not supporting EVN. That's why I'm going to implement this on GNS3. And before going to the actual configuration, let's discuss a little bit about the topology. In this video, I'm going to use 3 routers, which is R1, R2 and R3 and 3 virtual network. In your case, you may have a more than 3 virtual network. For simplicity and demonstration, I'm going to use virtual network red, which has VLAN tag is 100, green, as well as blue 200 and 300. Additionally, we also required IP address to their interfaces, which is connected to R1 and R3. So I have a 10.0.123/24 on left hand side, as well as on right hand side I have a 10.0.4, 5 and 6. In your case, you can use overlapping addresses because we already working on VRFs. That's why we can use the overlapping addresses. But for simplicity, I'm going to use these addresses. And one more thing that we need to discuss, on this interface, I'm going to configure IP address 192.168.1.0 as well as 2.0 on these interfaces. So let's go through the configuration and verification. So first of all, I would like to show my current configuration, which is nothing except to the IP address. So my gig 0/0, the IP address is 192.168.1.1 on router 2, gig 0/0, which is connected to R1 1.2 and 2.1, which is gig 1/0 connected to R3 2.2. So my underlay topology, or in my underlay network, I am going to enable routing so that we can able to reach from R1 to R3. So let's say, for example, I am going to use router RIP, and then after address family IPv4 unicast, and then network that I have a directly connected, which is 1.0 on R1, likewise on R2 router RIP, and then after address family IPv4 unicast, and likewise network 192.168.1.0 and 2.0. Finally, we're going through the R3. So let's say router RIP, address family IPv4 unicast, and the network is 192.168.2.0. So there we go. We have a network 1.0 and 2.0. So I have added actually network in RIP. In your case, you can use any routing protocol for your underlay network. So hopefully R1 come to know about network 2. So let's say so IP route. As we can see by RIP, your R1 come to know about network 2.0 and hopefully be able to ping to the network or router 3, as we can see. One more thing I would like to mention. So version include include iOS. Include iOS. This is 7200 and the current version of iOS is 15.2. So to be very clear, currently I am using GNS, and previously in most of video I have used my real physical devices or Cisco gear, in other word you can say. So once we configure underlay, now we're going to configure VRF top of the devices or top of your network, which is sometimes also known as the overlay. So first of all, VRF definition, which we need to define VRF. So for example, this VRF is RAID, as we have decided already. The next thing is what? VNet. So this command makes unique VNet tag, which is 100, and it is going for IPv4 address family, IPv4. There we go. Next thing we also need to define. After RAID we have green, so GREEN. VNet tag we going to use 200, and it is also we going to use for IPv4 address family. The next and last one is, which is blue. So it is blue, and then after VNet tag going to be 300, and it is also going to work for IPv4 address family. So once we define VRF on R1, we supposed to have same VRF on R2 and R3 in order to work properly. So let's say, so run, and we're going to copy VRF from R1 and going to paste on rest of router. So come on. There we go. So we have a blue, green and red. Let me copy from here and go through R2. So exit out on globally, define this VRF. Likewise on R3. And there we are. Next thing is, these interface should be trunk interface for easy VPN. So gig 0/0 on R1, on R2 gig 0/0 and gig 1/0, as well as R3 gig 0/0, because these interface are working as a trunk. So let's say first of all on R1, configure terminal interface gig 0/0, and there is a command VNet trunk. So this interface going to be work as a trunk, and obviously you can use a list in order to restrict particular VRF. You don't want to send traffic for particular VRF for red or green or blue. On that case we can use the list. So likewise, it is red, green, blue. I believe we have defined successfully. We have a blue, we have a green, we have a red, which is going to work as a IPv4. The next thing is exit out, interface gig 0/0, VNet trunk interface. Likewise, interface gig 0/1. So it is eating my CPU, that's why it's going to be little bit slow. But as long as it's working, I have no problem. Next interface is gig 0/1, and it is also going to work as VNet trunk. Finally, we have R3. So gig 0/0, VNet trunk. So once we define VNet trunk, now we also need to define IP address on this interface. So it may take little bit time. Meanwhile, I am going to pause the recording and assign IP address on these interfaces. One more thing I would like to discuss before assign IP address, we also need to define for which VRF we going to forward traffic, because once we assign IP address and we attach VRF, it going to remove IP addresses as we discuss in VRF Lite. So make sure about that. So, alright, I have assigned IP address successfully. You can see on R1 we have an interface E0 to E2/0, E2/1 and E2/2. So first of all we need to define VRF and then after IP address, VRF and then after IP address. Likewise on R3. Then final thing what we need to do, we need to enable routing on top of your VRF. Since we do have a different network, obviously we connected to multiple router, that's why we require routing protocol inside VRF as well. So let's say inside your R1 we're going to use router enhance IGRP, and for example we're going to use the name enhance IGRP, which is test. Address family you can use the legacy enhance IGRP as well. So address family, it is IPv4 unicast, and then after we need to define for which VRF we want to configure this one. So first of all RAID, and it is autonomous system 1. For simplicity I am going to add entire network and exit out and define VRF RAID and then after green, and then network 0.0.0. You can specify, you can configure a specific network in your case, but in my case for simplicity I am going to use all. So red, green, and finally we have blue, which is this one, and the network is 0.0.0.0. Likewise we also need to define routing on R2. So let's say router enhance IGRP, and it is under name mode test, address family IPv4 unicast, and it is a VRF for RAID, and also we need to define autonomous system. So let's say network is 0.0.0.0. Likewise we have next one red and then green. As we can see the neighbor come up, and network is 0.0, red, green and blue. This is going to be blue one, so BLUE, and then after network is 0.0.0.0. Likewise on R3. So exit out, router enhance IGRP test, address family IPv4 unicast, it is IPv4 unicast VRF, and the name of VRF is RAID. Also autonomous system 1, network 0.0.0.0. RAID, likewise green, come on, so RAID and then after green GREEN, and the network is 0.0.0.0, and finally red, green and then blue. Actually process going to be very slow because I am running GNS3 on my laptop, so that's why. So red, green and then after blue. Excuse me. It is very slow. It's supposed to be not too much slow. BLUE, blue. Finally the network is 0.0.0. So there we go. So once we enable routing protocol, now all devices come to know the entire network which we have used in VRF. So let's verify from the R1. So we have couples of way to verify. First of all we can ping VRF and then name of VRF is RAID, and we want to send packet to other end which has IP address 10.0. On RAID we connected a network 1 on left hand side, on right hand side we have network 4. So let's say we want to ping to 4. We can see we getting reply back very soon. Yes, since as I told you earlier, because of my GNS, my CPU is going to eat up, and there we go. Or other way, we can also see from the RAID, if we're looking to ping to green, so we have a network 5, we supposed to not get reply back because it is belong to other network. So hopefully we will see the reply is not coming from the network 5.1 because of it is separate. It is separate virtual network. On other hand, you can also go to verify using router context. Yes, inside router context we can define VRF, and then after let's say we have VRF RAID, and now every time you don't need to specify on which VRF configuration you're looking for. For example, if you go for so IP root, you don't need to define VRF number. So as we can see from the enhance IGRP, we learning this network. Likewise, we can exit out or we can ping directly without using a special command, which is, so it is 10.0.1.1. From RAID we supposed to able to reach from 1.1. There we go. So you don't need to put every time VRF in order to verify, because we are already working on that particular VRF. So it is make very simple to verify. You don't need to execute every time VRF and then after the command, the actual command like ping, telnet and so on and so forth. Finally, one more thing I would like to show you. Whenever we create a trunk, actually it create so IP interface brief, it create a sub interface. But the weird thing is that on sub interfaces we can see we have a same IP address out all sub interfaces. This is make unique your easy virtual network. So generally we cannot assign same IP addresses on sub interface, but whatever tag we have defined, your router automatically going to create a sub interface along with the same network out every devices. So again, so IP, let's say interface brief on this router, you can verify. We're going to create tag on both of direction. For simplicity, I am going to use this thing. Now you can also add couples of switches and connect thousands devices inside your network. In my case, I'm not going to use on that way. So for simplicity, I want to make this video as possible as short. Additionally, you can also, as we discussed already, additionally you can also redistribute, or other word you can say the replicate one VM's network to other VM as well as the global's network for access internet, for DSCP or for some other services. In this video, this is all about.